Alright, here we go. Here we go. Oop. We're live. We are in. Thank you for 4 gathers for the follow. Always nice to get a good early follow on the stream. Alright, so PlayStation 2 development. We're back. We're at it. If I can remember how to quit this spinning cube. Cool. So, I thought about a few things off camera yet again. Let's get into our folder, 3D test. Now, gonna cut a new branch. Check out stream 2021-08. Is it the 15th today? I think it's the 15th. Let's double check. As always, do just give me a shout if you can hear me out there. Always good to just double check my microphone config. Also, anyone rolling in may notice my computer is in a slightly different place. I'm very excited today to have my computer off my desk. I've got so much more room for activities here now. It's phenomenal. Cool. So, new Git branch for a new stream. All of this code is on GitHub. You can follow along stream by stream. You know, all these branches get pushed to github.com. If you're watching this on YouTube, the repository will be linked in the video description. So, let's start by showing off what we had last time. Docker build. If I can remember my password. Just a few little errors here as we get into it, but this is fine. We have a magnificent spinning cube, okay? And this is very exciting, but there are a few problems with it. The main problem being that, as you can probably see, there is no Z ordering, right? So the back faces of our cube are drawing in front of front faces. It makes it look really janky. It makes it really hard to tell where the front is. Also, this logging is just going like into another dimension. This is using a fair bit of the Emotion Engine, like 60% just to draw one cube, which is kind of weird. The Emotion Engine here being the CPU of the PlayStation 2. So there's some stuff to look into here, but the big thing is to think about how our Z is being handled. If we go into our main.c, if we look at where we're building our main draw buffer here, we disable our z-test before we clear the screen, because when we clear the screen we want to just fill every single pixel. We don't care about the Z at all, so we're just going to ignore it while we clear the screen, and then we're going to enable it and draw our model. And there's something very interesting that I noticed. If I jump across into gs.c, the code where we initialize the graphic synthesizer, we set the Z buffer depth test method to 0. Now, let me pull up stbig. If I go over into PS2SDK, there are some wonderful people who have like defined, all of these magical constant numbers. And if we look up the corresponding z-test method to 0, so let's grep z-test. Let's not ignore case. So z-test method all fail is 0. So in other words, we're setting this method to say that every pixel should fail and nothing should be drawn while our z-test is enabled, which is a problem. So as it turns out, we also have this enable flag, which for some reason I initialized to 0, I guess because I was just trying to draw a triangle and I didn't care about Z, and that was great. If this had been 1, then this 0 would have meant nothing would draw. And so now if I do this again, if I go back in, make docker build, make run, we should see nothing drawing, except for the clear color when we clear the screen. So that's perfect, that's what we expect. So now if I come into gs.c, go into where we have our method, and I want to change this, I want to change it to mode 3, which is, I want to change it to greater. Do I want to change it to greater, or do I want to change it to greater equal? Let's change it to greater equal for now. So when we have our Z buffer, when we draw a fragment, it's going to test that pixel against the corresponding place in the Z buffer. If the coordinate, or if the coordinate of that pixel, I guess the like 3D coordinate, if the Z component is higher, then it will pass the test. So towards the camera is positive Z, I believe. We'll find out. So Z method greater equal z-test method greater equal. Okay, so now if we run this again, we should see a nice cube and none of those awkward back faces. And that's a little bit better. It looks like there's a little bit of fighting still, so let's go back in and let's go where we said greater equal. Let's just say greater and see if that fixes it. I don't know if this is a good fix. Interestingly, has not completely fixed it. Okay, but that's better, right? That's definitely better. This could also just be a quirk of our color, I guess. I wonder as well if we're actually drawing the faces in the wrong order. So what happens if we come in and multiply our z by -1? That would be in draw.c. When we calculate our final z, let's just chuck, hold on, no, where is it? Z, pos2 equals int, pos2, let's go -1 times this. Now if we build it, run it, that looks like we're drawing our cube inside out. So that looks like we're drawing the back faces in front of the front faces. So that's good. So we've got our Z in the right order. So I wonder why that is. We could probably also tweak our color logic. So if, I don't know, that's weird. But I mean, that's a hell of a lot better. It may even just be some like corruption here. Now there's definitely like triangles drawing at the wrong place. I really should slow this cube spinning down. I think that would be a good place to start here. So let's go 0.1, let's go 0.01. And let's stop moving the camera for now. We need to do something about this camera. I don't know what. Let's actually rotate one of the axes slower too. I think that'll be better. So if we come in, okay, we can see something's still going very wrong here. Oh dear. Oh dear. Still, we've made progress. Okay, this is better even though something's still a bit funky. And I'm guessing we're just seeing like some of these coordinates fighting each other. So if I pause this, it looks like we have very distinct vertex depth values. So that's weird, that's weird. And we probably want to rescale our Z as well at some point because our Z at the moment, it runs on like, well, I don't really know if it matters what scale we consider it at, I guess. Like, I don't know if the PlayStation 2 is going to consider the sign of the Z, right? We're using 24-bit Z. We initialize that, GS and knit. Yeah, so we send in, we tell it we're going to use 24-bit Z. I don't know why necessarily 24-bit, because it uses the same amount of memory as 32-bit. For some reason, programs don't seem to use 32-bit. I don't know why. That's something for me to learn about in the future. But, all right. Either, I mean, this is workable for now. I would just really like it to look better. Let's go back into draw. This should all be fine. This all looks fine. This all feels fine. As Z, see what probably would be good as well if we maybe normalize the Z on a scale of 0 to 1 and then multiply it by the maximum 24-bit number, for example, or the maximum 23-bit number, just so we don't hit any sign conflicts potentially. If anyone's coming into chat who knows how the PlayStation 2 handles the sign in the Z buffer, do give me a shout. I would love to hear it. You know, just by any chance. So, so I'm trying to think the best way to normalize Z, and that's probably actually in our matrix step, right? Like when we're actually doing our matrix math, we want to get Z in the range of 0 to 1 or -1 to 1. That doesn't really matter. We can deal with like -1 to 1 versus 1 to 1. That doesn't matter. So maybe we leave it for now. There is one other thing that I do want to do actually, where for color we're kind of normalizing our Z against this range of 1000. I'm gonna come in and I'm gonna say 1000 minus Z over 1000. And that's gonna mean that darker vertices are away from the camera, I think, right? Does that make sense? Z, bigger Z's towards the camera, bigger Z is, oh no, that should mean that darker vertices are towards the camera. I'm just gonna change it and see what happens. Make a run. I changed something. So that vertex. Oh, you know what else? You know what's a problem? We're actually doing this with shading disabled. We haven't turned shading on. So let's hold on. So let's it's in mesh, and this is a really like leaky abstraction. The fact that we're setting the primitive mode when we actually load the mesh, but this will be fine. I think the first field here is the shading value. We just set it to 1 because that's enabled rather than 0, which is disabled. Should be fine. So if we build this, if we run this, that looks a bit smoother, but we're still getting this like ordering issue. I'm not even convinced I've actually gs.c, not convinced we've actually fixed this. Z enable greater equal ZSM mask. Do I need to set mask? What's ZSM? PSM. I'm not setting the PSM to anything, which is odd. Alright, let's change a few things and see what happens when we run it. That looks different again, but it looks consistent. It's stable this time, so that's good. Let's get rid of that mask, because that might be it. FB mask, Z mask. The PlayStation 2 can do all kinds of really awesome stuff with Z. And just drawing in general. There are lots of interesting drawing modes, and we're going to get to play around with some of them, especially when it comes to fog. I'm excited to fiddle around. This is better, okay? We're not having faces fight each other anymore, which is phenomenal. But they're not drawing in the right order. You can also see, I don't know if it's obvious, but this shading is now smooth, right? Like the what's the word? The interpolation, I guess, between vertices, it looks a lot smoother. It's very subtle. I really need to increase the range these colors are going over, make it more drastic. We're calculating color, let's say 0.0. Let's get rid of this. I think this was actually a mistake. I think Z. Let's maybe put it over a range of 2. No, let's put it over a range of 500, right? The problem is it's too much. And let's make the color, the multiplier bigger. That looks like that's more exciting. And so you can see there's actually some interpolation between these colors. For some reason, this is going all the way to 0. I guess it's not like, hold on, it's because my Z goes into the minus. So I could be smart about this, or I could just say Z plus 500.0f. BODMAS, that, hold on, I need to put an extra bracket in there. Okay. So there we go. So now we've got a much nicer colored cube, much more drastic difference between the vertices. And if we follow a vertex through, it's really hard to follow a vertex through. It looks like they get brighter as they come forward and then actually wrap around to complete black because they like get too bright, which can happen. Let's multiply it by 90. That looks better. I think that's still overflowing somewhere. Anyway, these are very small details. The big problem right now is why does Z hate me? Man. I was so sure I had this worked out. I was so sure. I was so confident. Let's go back into our GS initialization code. Let's change this to greater. We changed it to greater equal. It's definitely enabled. That's very important. If you don't have enabled set, it overrides your method with everything passes, which is not what you want. We're definitely setting the depth buffer like width. That's important. That's good. Z-test. So I guess what's the difference between Z-test method greater equal and Z-test method all pass? So if I set this to 1, how different does it look? Like, is everything passing? Probably. No, because when I have this set, we get like more fighting and we get this kind of jitter, which is different to if I have it set to gs.c. If I have it set to, where are we? 1 Z-test method greater. This is at least stable, apart from the vertex color. The vertex color is a bit messed up. Oh, weird. Also, there was something else that I realized when I'm dividing by 500 here. Let's go back to dividing by 1,000. And that's still too far out of range. Let's divide by 2,000, I guess. That's better. It looks like only one vertex is ever really close to the camera at a time. Why is this inner... Are they even inner faces? I'm very confused. So this goes around. This shading is nice, at least, right? You can see that things are being shaded, which is a good, important step. Going absolutely crazy. Pos 2. It's a floating point number. We're clipping it down. See, maybe we do need to think about the range this data comes in, get it normalized into... Okay, so if we run this, right, we let it run for a second, our vertices are kind of going from negative 400, negative 5. So let's assume that they're in the range of negative 1,000 to 1,000, right? So if we want to get it in the range of 0 to 1, we take our pos. So Z. So we want to, if it's negative 1,000 to 1,000, we want to say pos 2 plus 1,000 divided by 2,000.0 f. We need to do some brackets. So this should give us a number in a range, if I put a semicolon at the end of the line, a number in the range of 0 to 1, which is good. And then we want to multiply that by some magical constant. So let's call it Z max times this. And we'll put an int out the front. Okay, so, and we'll define Z max to be, let's say it's 2 to the 20, 2 to the, so what would that be? 2 to the 20 would be 2 to the 10 times, so 1024 times 1024. So 2 to the 10 times 2 to the 10 is 2 to the 20. So this should be fine. Make a run. Okay, well that's good. All of our cube is now one color because we're reading a different value, a different kind of value. Now when we calculate this color, we want to come in, we want to go pos 2 divided by Z max times 1.0f times 1.0f. We need to make sure that the division is done on floating point numbers. Times, so we get this ratio, and then we multiply it by 0x FO, and then we cast all of this down to a char. I think this is fine, right? This should, I forgot a semicolon. Line 80, line 39. I've been doing too much Golang. That's the problem. Cool. So if we make run, that still doesn't give us any color. It looks a bit nicer. It looks nicer because we can't tell if the triangles are fighting each other with this like monocolored cube, but we're making progress. We're making progress. So first off, let's stop logging the Z position we're reading in. Let's log it after we've like casted it. So pos 2. And then this should be a number in the range of 0 to Z max. So I don't know why dividing it by Z max is giving us such a weird value. But let's see. Let's see what we get when we run it. 0. Everything's 0. Okay, well, I mean, that explains why we're getting such a weird value. Pause. So we're casting this to an int and then drawing it as a float. So I guess we need, to do this. T pos +2. And then this is complaining at me. Line 63. That's the end of the file. Something got unterminated there. I forgot. Oh, I'm short a bracket. Perfect, perfect. So if we make this, if we run this, that's a number, right? That's a number in the range of, it's quite a big number actually. But is it a big number relative to whatever 2 to the 10 is? So what if I come in, let's get rid of u. What if I, let's Python 3, 2 to the 20 is this. So what is this divided by 2 to the 20? Oop. 0.3. So not a very big number relative to the range. But then if we multiply 0xff by 0.3, we get, so what's 76 in hex? 76 in hex. 76 for 40. So it's 76 on 250. It's like, yeah, it's a, yeah. I don't know. So it's like a third of the way to red, right? So it should be, we should see some red. Draw.c, let's go in. And then let's just log this as well. Red component equals C. Does C give you a number? I don't know, let's do D. I can't remember. 0. Red component is always 0, of course, because there's something going wrong with our cast. Times 0.ff. Oh, because this is, if we multiply a number less than 1 by an integer, we're always going to get 0. It's going to be downcast to an integer. So let's actually change this to 255.0f. I think this will work. And that still doesn't work. It still doesn't like our cast. It's got to be the cast at this point. Let's maybe say int. Let's see if that works. Red component 0. Weird. Pos2. Pos2 is a float. Oh, I'm interpreting a integer as a float. That's the problem. So let's go int uint 32t. Z value is gonna be equal to this. Yeah, just a bit of lazy lazy conversion by me here. Let's say this is ZV, and then we're going to use ZV over here. Going to convert it back into a float, divide it by this magical Z max number, convert it to an integer, see what happens. There we go. And this looks like it's actually drawing in the right order as well. Huh, that's kind of neat. So we fixed our problem. It works. It's perfect. Our cube lives. These numbers, yeah, they're not quite in the range we want them to be, but it's okay. We'll survive. We can probably divide by a slightly lower number. Maybe like, let's try 1700 and see if that just makes our number a little bit nicer. Yeah, it makes our cube a little bit more red. Okay, well, we played around with our color generation and that seems to have fixed something. I guess drawing vertices with weird colors could actually cause some of the artifacting we saw. Probably not all of it. I imagine that this Z conundrum is going to come back and bite us at some point. But for now, let's call that a successfully rendered cube. Perfect. So we've got a 3D model rendering. Let's commit that, because otherwise, what are we actually committing? What have we done? We have calculated our Z differently on a different scale. This isn't really gonna fly long term, unless I guess we like kind of We'll have to think about this logic. We'll get rid of this info. We have to do this. Happy with that. And then, yeah, we've turned shading on. So draw.c, we'll just jump to where we're logging here. Fix Z buffer. I don't know. That's a really crappy commit message. If you're watching this, if you're an aspiring young programmer at home, write better commit messages than this. That is my advice to you. But for now, this will do. So the next big thing I need to think about is this camera. We're initializing a camera. We're initializing it in a draw, and we're setting up this matrix. And I need to work out what this matrix actually does, because I'm not totally sure. Like, we have this aspect ratio. We set these bounds. We need to look it up in PS2SDK. So let's do exactly that. Oh, man. Sorry, I'm just making sure everything's like running okay on the stream here. Man, my hair's looking wild at the moment. It's big lockdown vibes. Where are we? Workspace, PlayStation 2, PS2SDK. And what are we looking up? We're looking up create view screen. It's going to be, oh yeah, it's in 3D math, of course. EE, math 3D, source, math 3D, line 416. Perfect. So left, right, bottom, top, near, far. So we're defining like, we're defining something. So it's one of these. What does this look like? So 0, 5, 8, 9, 10, 11, 15, 16. So if we have a 4x4 matrix, hold on. I have done like this 3D math before. I just really need to draw out what the actual matrices look like so that I can think about it. Let's just get a nice 3000. Go 2B, 2B, 2B. I really like 2B, 2B, 2B as a background color. P. Get a nice soft brush. Go in here. Cool. So if we have a matrix, we don't really need to like. So 0 is 2n over r minus l. 2n over r minus l. Then we have 5. So 1, 2, 3. So 0, 1, 2, 3, 4, 5 is 2n over t minus b. 6, 7, 8 is r plus l over r minus l. 9 is, so this is your scale, right? What are these for? Is this it's not rotation, is it? It's I can never remember what these do. Top plus bottom over, yep, so t plus b over t minus b, far plus near, yeah, and so then this f plus f plus n over f minus n, 11, negative 1, and then 12, 13, wait, 1, 5, 6, 9, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, that's right. So 14, 2fn n over f minus n, and then this is 0. So what does this do to a vector, right? So if we have x, y, z, w, and this is our matrix, this is going to give us, oh god, am I really going to do this by hand? I haven't done this for quite a while. It's been a long time since I've done linear algebra, let alone live on a stream. So this gives us, so x multiplied by this, row by a column, row by a column. So this is an interesting row, right? Y, Z. So we scale X, Y, and Z by this. We eliminate W, I guess. We eliminate like our raw W. W is always going to be -1 times W. Or W is always multiplied by -1, sorry, in the final. Is that right? I guess that's right. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Let's go to our good friend Wikipedia. Go to our good friend Wikipedia. And what is this one? This is the view matrix. Camera view matrix. Wikipedia has actually has some really good visualizations of this, I guess. Really good explanations. So 3D coordinates, homogeneous representation. This is. So we've got a good friend, a 4x4. This is a 3x4. Hmm. 3x4? 4x4? 3D projection. Where are we heading? Sorry, I'm just gonna quickly check my phone here. X focal length. Cool. Cameras in 3D, the same works as screen Y coordinate, substituting X for Y. Yeah, this all looks perspective projection. 3x3. We can express the modulus coordinates. Create matrix multiplication. Okay. Yeah, so this isn't what I quite want. Reflection, rotation. Anyway, okay. Either way. This is a little bit different to how I've done 3D matrices before. It's kind of, hold on, actually I've got a, let me just pull up a cheeky little repo off camera that I've worked on. Data, Windows beta. CD. Oh no, hold on, I've actually got this in the repo. Wonderful PS2 math. So this is kind of similar, right? Kind of similar. So this would correspond to the. I actually like. There's no equivalent to like look at in the PS2 SDK library, so I might actually pull in some of this logic essentially. Translation, scale, projection, 0, 5, 10. Yeah, okay. So this is actually. I have done this before. I've done pretty much this before. Proj S. This is to do with your field of view. So this is calculating field of view as 2 times near over. Interesting. So this is literally calculating field of view by the like relationship between your left, right, top, and bottom. And then 11, -1, -4 over 5. So this is subtly different to one I've used before. I have also hilariously just like used this like -1 over camera Z, which has worked for me in the past. So we could do that. Cross vector scale. So you can see like I did a lot of manual grunt work to get this working. I did automatically generate this monstrosity. I just thought that was more efficient than like having a loop. So make rotation. I don't know if all of these are like quite right, but they seem to have worked in the past. Viewport is one that I'm not really sure on. Like I think this is missing from what we're doing at the moment in Draw. Create view to screen, create world to view. Oh no, so this. So we start in model space. and then we go into world space, and then we go into view space, and then we go into screen space, right? Like that's how this stuff works. Hi, 3 a.m. you should go to bed. Hello, Anakim, Luke. Good luck with your triangles. Well, I mean, hey, we've got more than triangle. We have got more than triangle at the moment. Triangle, that's old news, right? Make run. We've got a spinning cube. We're doing it. We're living the big life, living the dream. Bye. Thank you for stopping by. I appreciate it. Feel free to stop in whenever you want. Stick your head in, see where these triangles are going. I mean, they're still triangles, but they're actually doing cool stuff. All right. So. Rotation scale and translate calculations are fine. Do I want to override their view screen? Because I'm just not 100% view to screen. So it's the matrix that does this, but this is a projection. So when I've done this in the past, I've had a matrix after projection that mapped into view space, that mapped into screen space rather. So I'm not really sure where the screen coordinates come from, or maybe they're just not really, but they must be. I don't know. That's weird. Viewport. That's this one. I think. Maybe I'm splitting this over 2 matrices. Actually, no, that's what this is. Except I'm not multiplying. Oh, this is similar to this, but different. Subtly different. Why have I... Because this was a midpoint offset? I don't know. This is weird. Maybe I need to brush up on my linear algebra. It's crazy. Didn't expect this to be such an issue. The other thing that would be good to have, though, is look at. So I need the cross product for this, and this doesn't have a cross product, does it? This doesn't even have a dot product. Dot. Yeah, so let's do some math. I'm not going to use PS2 math. I'm gonna start new math functions that actually build off of the PS2 SDK function. So let's clean up what's here. Okay, so the first thing we need is, let's start with the dot product. That's fairly simple. Void vector I'm pretty sure we're universally working with 4D vectors here. So we're going to go vector. Actually, let's just go vector A, vector B. And this actually gives us a float. Or do we just start with cross? I mean, no, we don't need it. Let's start with cross. So and I think this usually A, B, and I can never remember the formula because I didn't do that much linear algebra at uni or high school. We will just grab this. This will be completely compatible. 0, 1, 2. Is this fine? Can we do this if it's a 4D? Yeah, well, because we just kind of ignore W, right? Is that okay? That's how I've done it in the past. It should work. It should work. It should work. And then if we go to look at... What was norm? That was just, yeah, okay. Normalizing the vector. Cool. Oh, we'll deal with that in a sec. Matrix out. Dot, dot, dot. I don't know what args we need for this. And then we're gonna paste this in. This also now no longer returns anything. Look at I center up. So we have vector I. I don't know what center is, but anyway. So we do have these nice assembly functions for doing some of this stuff, right? Is there an assembly function for cross? Ooh. Ooh, that's actually interesting, isn't it? How do I look that up? Is that in the system? Where in the system hardware manual is that? EE users. It isn't EE users, is it? It's in the EE core manual. Should I just show the system hardware manuals? Do I care? Do I care? System hardware manuals, EE core instruction set menu. Okay, I'm going to show this on camera. Let's do it. Let's live our best life. Sony, please no sue. Okay, CPU instruction set. So, does this have the vector? So this is MIPS 3 basically, right? This is MIPS 3 with some MIPS 4 stuff. Man, freaking love these instructions. F. Move from data value breakpoint register. Here we go. The FPU instruction set. So, floating point reciprocal square root. Beautiful. No John Carmack bit hacking here. Sub v mol word. No. Do they not? W instruction. Do they not have the vector instructions here? What's going on? V wait. Oh, FPU. Sorry, no. Whoa, what am I doing? I would need the. Oh, that wasn't what I wanted. I need the VU core, I guess. Let's see what the VU instructions say. If you've never seen this before, it's pretty wild. Okay, so registers, how they work, micro mode, flags, instruction set. I think it's at the end. Pipeline operations. Micro subroutine exception. Is my screen slightly orange? Hold on. Interesting. Maybe I'm just going crazy. Okay. I think these are the instructions this is doing, right? Yeah, like mad product sum. Mad. I don't know what mad a. See, it's slightly different, right? Mad a something accumulator. V mul ax mul. See, I don't know what x is here though, right? Surely it should be mul aq like this says. Cool. Hold on, just getting another message here. V mul q. So what am I looking for again? I'm looking for a cross product. I mean, there's not going to be anything quite that fancy, but there's got to be a normalize. Maybe not a normalize. I guess not, right? Because this stuff is all just component by component. So normalize dot. Oh no, floating point values. Normalize dot value. Blah blah blah. Non-normalized value. That's cool. Normalize. Can we just like scroll on a little? Infinity non-normalized number. Differences from IE. Pages intentionally left blank. Micro mode. Flags. Here we go. So micro mode is actually what we care about here, right? Is this flags? Back flags. Zero flag, signed flag, underflow flag. Calculation results in underflow. Yeah, cool. So that's our status stuff. Clipping is like really interesting. We actually get instructions about clipping, which is fun. I'm looking forward to having to do with that. We will have to do with it because the PlayStation 2 really doesn't like you drawing out of bounds. That is not a cool thing to do. Abs I to F mini. Either way, I don't think this is going to do what we want it to do. Zero normalized value. X mad applications, a double except in generally if one is trying to place the appliance. X 1 0 condition calculation results X. This isn't relevant to what we're doing. Priority FMAC pipeline. This is kind of cool. Oh, look at this. This is just like the nerdiest thing in the world, right? Like literally how these instructions are pipelining operations. That's incredible. So is this like a data dependency that's being shown here? F to S. Anyway, that's really cool. We're going to have to think about this. Showing stools. Oh, man. I did a uni course on hardware and we had to like simulate a bunch of RISC-V stuff and show pipeline stools. And we had this like virtual CPU we had to reason about. It was really, really cool. It was really cool. Oh, this is so awesome. Man, we're going to have such an efficient pipeline once I've read all this. Or not, because optimizing this stuff is insane. Micro. So this is micro. So we don't want micro, we want macro. Where's macro mode? Where's that described? Macro mode. Correction was made. Okay, I'm scrolling like a scrub. VPU execution mode, micro mode. So it must be chapter 4, micro mode. Chapter 5, lower instructions. Macro mode, here we go. Macro mode instruction set. MIPS. Yeah, okay, so 206. Cool, coprocessor transfer instructions. Interesting, I don't really understand this. So I was wondering what LQC2 was. Floating point data transfer from EE to VU. Cool. How does it work? I don't know. Coprocessor branch. That's really, that's wild. BCF. I imagine we don't have many BCF instructions, but there must be a few. So absolute addition, add broadcast. The broadcast stuff's really weird. I don't really understand it yet, but I'm going to have to at some point. Output, broadcast I. This is all good. What's VOP mul A? Anyway, I'm getting a little bit distracted here. I am curious though, because it feels a little... Oh, did I accidentally... Okay, that's cool. I accidentally flattened some stuff out. vmul.xyz, that's all good. But vmul AX, right? That doesn't look like there's an instruction here that corresponds to that, so I don't really know what this is getting compiled to. So that we've got to work that out at some point. Maximum, multiply and add. Multiply and add is a super cool instruction. Multiply and subtract, maximum, minimum. Outer product. Cool. What's the outer product? Is that I don't know what the outer product is. Is that another name for like vector outer product? Is that another name for the dot product? Outer product. Oh no. Is a matrix. Okay. So it's just some like... Ah, yeah. The other multiplication. Yep. Cool. Okay, so in other words, we aren't going to have a normalize instruction that we can easily just like do this with. Integer load word, random unit. Interesting. VRNet, I like it. Wait queue is kind of cool. Macro subroutine. You can call a micro subroutine from macro mode. That's really weird. Then flags are going to be different. It's going to detail all the pipeline stuff again. This stuff is really cool. Like, holy shit. I probably shouldn't have shown that. But anyway, the cat's out of the bag. So in conclusion, void vector. We need to write error normalize. Vector out, vector in. And in this case, so what? You just... How did I do it before? Okay, again, like there's probably a much more efficient way to do it here. It's probably a much more efficient way to do it here. I was literally just calculating the length. I would love to try and do this in assembly, right? I would love to try and do this in assembly. Oh yeah, and then I was using dot. That's kind of cool. I think that's a good way of reusing a bit of... Anyway. So float lan equals... let's call this A because it's going to be one less character to type. A0 times A0 plus A1 times A1 plus A2 times A2 plus A3 times A3 plus A3 times A3. I'm gonna float script. This means we have to link against libmath, I think, which is always fun. I don't know how that's implemented in PS2 SDK, but I hope it's using instructions, like the actual hardware instruction for this. So we have the length, and then out 0 equals A0 divided by len. This is fine. And then S01 G 02. Cool. Then we don't have to return. So normalize our vector. And then we also, I guess we'll write out a subtract function. It's kind of crappy, but anyway. Vector sub. This is subtract b from, this is a minus b. Yeah, so out 0 equals a minus b, 0 minus b, 0. Cool. So now, so we're going to say vector sub z I center vector normalize z. Cool. We're just saving it where it comes from. That's fine. That works in this case. Vector cross. We're saving this in x, we're crossing up with z, and then we are normalizing x. We're writing to y, z crossed with x, and then we're normalizing y. Again, definitely, well, I don't know, I guess you only do this once per frame, right, for your camera, so it doesn't have to be super efficient. Then we are going to go matrix out. Oh no, well, we don't have to, we already have an out matrix. Unit matrix unit out. Cool. So out I equals xi, and this is all going to be fine. This is all going to be fine. These coordinates are good. This is like nice and condensed. This is a, yeah, center, yeah, cool. Let's see if this works. So does this, so where do we multiply this in our chain? Because this is where we go from world space to camera space, right? So do we multiply by this? So what do we currently have for this? Draw.c, we currently have world view, yeah, world view, right? So it's here, So rather than this, we say matrix look at d world view, and then we take in an I position, which is our d, camera pos. We take in our center, which is, I'm not really sure. Does this also not factor in rotation? Oh no, it does. It factors. It rotates based on where we're looking. Yeah. Cool. Center. Is center Is center what we're looking at? Because like, yeah. Center's the center of the camera. Okay. D camera target, and then we take D up. I think we have an up in our raw state, our render state even. Camera. So rather than camera rotation, we now have vector camera TGT. Do we have up? Where does up come from? How do we calculate up? What view was it? Also, color. I guess we need to add it. Am I going crazy? Create world. Oh, sorry. So create world view. Does this hard code translate rotate? No, I guess this doesn't care about up. Draw.c. Get rid of create world view. Add up vector here. And then we go into main. Up. Do we have an up? We really don't have an up, do we? Camera position. Camera TGT. Well, that's fine. We can actually just ignore that now. It's going to point at 0, 0, 0. Dot. Actually, we don't. Again, I don't think we need to do anything fancy here. Let's draw.c. Let's just hard code up for now. D up 0 equals 0. 1, 2, 3. Except 1 is going to be positive 1. Because it's going to point to the sky. We're going to say y positive is going to be moving up towards the sky. Okay, so now we need to link against our math library. We need to go into math .c. We need to include what's this called? Math 3D. .h. We need to include math.h as well because we're using script here. This comes from math.h. Cool. And then we also need to add math.o. And then actually okay, so we're gonna remove what we currently have PS2 math, and we're gonna make a header called PS2 math because we can't have a header called math because that doesn't work. There already is one. So none of these need to be exported, just this matrix lookat function. If and def PS2 math h define and if. And then we just need our beautiful friend the semicolon. This needs to include math3d.h. We go into our friend draw.c. We say include not up here. We go include PS2 math.h. And then we make and hope this works. First compiles first time, obviously. Let's just jump in here and get rid of log so that this is a bit cleaner. Center. I called it C, didn't I? Math.c, line 31. Just called you C. And I think that's the only... Nope. Just called you C. Okay, few little things here. Vector apply, multiple different vector normalize. Interesting. So, apparently this is already defined. Does that mean I can just jump in and get rid of my definition? Math.c. What if I just like... Is this just going to magically work if I get rid of this? This is already defined somewhere else in PS2SDK. It is. Okay. Beautiful. And that still works. So, I'm pretty happy with that, right? We have just built ourselves a better, what's the word I'm thinking of here? A better way of generating this matrix, right? A way that I prefer, at least. Because rather than specifying a rotation, which can be kind of janky, now instead we actually just specify a point in space. So for example, if I wanted to spin this camera around, I would say that, what's my thing called? Is it D? It's r.camera tgt. Well, not spin it around, but like move it from left to right. So let's say our camera target plus equals 0.1 f. And let's see what happens if we start looking to the either left or right, depending on on which direction this is. I think this should be to the right. I think that's positive x. So make run. Okay, and our cube stays in place, but our vertex color gets messed up. So something is going very, very wrong here. Very, very wrong here. That's not good. So, and this, I think this is because we're mixing two things, right? So if we come back into draw.c, I think we might have to change this to something else. We might have to generate our view matrix in a different way. So let's do our old friend, copy something that's worked before. Look at multiply viewport by projection. Viewport by projection. Viewport projection. Viewport projection. So let's just write our own version of this function for now. Void viewport. We'll parameterize it. We'll have an x, we'll have a y, we'll have a width, we'll have a height, and we will have, that's all. So we'll say, let's rename this to M. I don't like typing. I don't like typing characters. M, matrix, unit M. We'll start with the unit matrix. We want things to be nice and straight down the middle. M3 is going to be x plus w over 2.0f. M7 is going to be y plus h over 2.0f. M11 is going to be 127.5. I'm pretty sure this is something I've copied. I don't know. I can't remember exactly what this is. This is like an offset of, well, what? Hold on. What is it half of? 127. It's half of, I can do this. It's half of 200 and, what is it? 240, 250, 255. It's half of 255. So that's weirdly like, it tastes like a bite to me. There's something bitey about this number. M0 is going to be width divided by 2.f. M5 is going to be height divided by negative 2.0f, because we're flipping the y-axis around in this case, and M10 is going to be 127.5f. Let's see what happens if we use this viewport instead. D view screen 0 0 0 644 80, maybe. Make run. Oh, that is different. That is going to be different. Okay, so we're doing math. We're doing math. I think I might actually have to go and think about this one off camera for a little bit, because I'm apparently less prepared for this than I expected to be. I expected to pull in a couple of things I'd done before and to have this work. This is probably not that hard to fix, but linear algebra is not my strong point, and doing it on stream just makes it that a little bit harder. So I don't know. What I might do for next time, I'll work out what the linear algebra is, so then we can start writing some actual gameplay logic. I just got a few extra viewers come in. Thank you very much. I'm gonna call the stream there because I'm just gonna sit here and get frustrated doing math, which isn't what anyone wants to see. But yeah, 3D math kind of sucks. But no, it's awesome. I like linear algebra. I'm just not good at it, and I don't know the math behind it well enough off the top of my head. I've done it all before. It just hasn't like stayed in my head. So yeah, let me let's go into draw. Why don't I just get rid of the viewport matrix, by the way? I probably need to make sure it's set to a unit vector, a unit matrix at least. Matrix unit D view screen. Oh, Stranger rating with a party of 78. Hello, thank you so much. Holy crap. Homebrew raid, awesome, welcome. Thank you so much for coming by. I was actually about to call the stream. I think that's a good sign that I should persist with this a little bit longer. I'm just going a little bit crazy, you know. I've done all this cool stuff with the PlayStation 2. Let me show you. Oh no. Where are we? Make Docker build, make run. Is this going to do anything? This is. So this is a spinning cube rendering on a PlayStation 2 emulator. It's pretty cool. It's getting there. And I'm just trying to improve the 3D math. And I'm realizing that I'm not as good with linear algebra as I thought I was, which is awesome. Professional gardeners. Can you teach us how to code? I would love to learn about gardening, honestly. I wish I could garden. That stuff's amazing. Thank you so much for the follows here. We have Nico Neo, we have Every Release, we have Kakashi. 3D Maths and Cameras makes me sad. It's just a big hassle every single time. I've done it before, I've gotten it working before, and then I've forgotten everything. So that is drawing without a viewport matrix, right? I drew this cool picture, right? I'm thinking about it. PlayStation 2 stuff is a little bit different if you've done like OpenGL, because you have to actually manually do your screen transformation, right? OpenGL, you want to get your vertices into the range 0 to 1 or -1 to 1, right? And then it does the screen projection for you, right? It like puts it into screen space from there for you. On the PlayStation 2, we actually have to do that by hand. We have to care about our screen resolution. We have to build a matrix that understands that for us. So I'm building this off of PlayStation 2 SDK, and PlayStation 2 SDK comes with a few functions that do this. Unfortunately, they don't seem to be doing exactly what I want them to do. So if I run this is pretty good. I'm trying to move the camera, and instead of moving, it's just kind of messing up the depth of our cube. It's doing something weird. It's not working. It's not working the way it should. So let's go into main.c. For now, let's just like axe this camera movement. Let's just pretend this doesn't exist. How is Haskell? Man. I think weird hand gestures perfectly sums up the process of getting stuff into like the right space for 3D math. How's Haskell? I'll watch that clip in a bit. I won't pull it up right now. I actually have my chat up on a different computer, so it's hard for me to open links from chat here. Also, Rich Handler, thank you very much for the follow. I appreciate it a bunch. Oof, 56 viewers. This is popping off right now. So, it'd be good to make something happen here. It'd be good to make something amazing happen here. Let's think. Okay, so if I go into math.c, I've got this wonderful lookout matrix. I'm slightly confident this might be working. I'm not totally sure. This looks right, and I've actually used this to some effect before, like this exact algorithm. I'm pretty sure this works. Turns out that the library comes with a vector normalize, so we don't need to do this. We're using a PS2 SDK definition of a vector, which is just an array of 4 floats. They like capital letters. This is cool. I'm happy to go with this name. My cross product feels right. It tastes like the right kind of cross product. I'm fairly confident this is what I want it to be. If we go into draw.c, this I don't know exactly what this viewport matrix is all about. I'm just kind of like copying from something I'd done in the past. One important thing about this is that I was actually flipping the Y, but compared to the PS2 SDK version of this, which is create view screen. So this is all code written by people much smarter than me, including a bunch of like optimized PlayStation 2 vector unit coprocessor assembly, which is really cool. Cross product ignores W. I feel like I should be able to ignore W, right? It's not that important. For that part in the chain, right? Like I feel like I should have deprojected my vectors by the time I get... Oh no, wait. No, sorry, I'm up here. So I'm in this part, right? So I don't know, I feel like I can ignore W. I've only ever done 3D cross products before when I've done this stuff, and it's usually fine, but maybe I'm just missing something. So I think I've actually just recreated this as well. So 0, 2 times near over right times left, or width divided by 2. Oh, no, I know what the difference here is, right? So this is, I'm just like taking the width and then doing something with like the midpoint, whereas this is like calculating the width by subtracting left from right. Sure, it's my fault. So I have run some of this stuff on real hardware. I've got some videos of things I've actually like run on real hardware before, which is cool. In my current streaming setup, I don't have a PlayStation 2 to just like test stuff and show it up on stream. I am accepting donations if people want to help, finance me getting that set up. That would be beautiful. I do have information about that in the description. No pressure, of course. Just having people come and hang out is awesome. PS2 SDK is pretty accurate for this stuff. And especially when it comes to 3D math, it's all me. 100% me. But yeah, some of my issues getting like the depth buffer and stuff set up may have been resolved quicker if I'd have tested more on real hardware. Yeah, trying stuff on real hardware is really awesome, and like especially once you get controller stuff working, which again isn't straightforward on a PlayStation 2. We've got some really fun stuff coming up in the future to get all of this really weird hardware working. If you don't know much about PlayStation 2 hardware, oh boy, it's a wild ride. So I'm pretty confident that this is actually gonna do what I want, and I don't need to build my own viewport. The only thing is it's on a weird scale, right? Like I don't know why -3 to 3. The thing I'm missing at the moment is where we go, like where we get actual screen coordinates from, right? Because our screen is in the range of 0 to 640 and 0 to 480, like in width and height. And so I don't know if these are numbers that just happen to nicely map to that at a certain scale. C Films. Hello, how am I doing? I am doing wonderfully. It is a nice sunny day in Melbourne. We're in lockdown. So it's a good day to hang out, write some code. And yeah, it's awesome to have so many people stick their head in and have a look. Binia, thank you so much for the follow. This is C Code. This is hardcore bare metal C. We're on a system that has very little restrictions. So I've kind of demonstrated this a few times, right? But I can just write volatile. If I know how to spell. Volatile. There we go. P equals, I can just like make up a pointer, and I own the pointer on the system. I can write whatever I want to this. There's no operating system on a PlayStation 2 to stop me. So this is a really awesome embedded system. And yeah, we're just writing C. The toolchain does support C++ as well. I tend to prefer writing really simple, minimalistic C. Especially when it's like doing weird bit hacking. So if I go into where we actually do our transformation, where we take our mesh and we put it, we multiply it by our kind of, model view projection matrix, and then we convert it into the fixed point 16-bit format the PlayStation 2 rasterizer or GPU/rasterizer expects it in. We're doing some really fun bit hacking here to get this to work. What's the first thing viewers should know about C programming language and code? Look, I think people like make a big deal out of pointers with C. Pointers, you have to have a decent model about like what your data represents, right? So think about like, I don't know, it's hard because I've been doing C for so long, so it just kind of becomes second nature after a while. Think about, like, draw a picture of what your data looks like, I guess. Think about what's a reference and what's a value. Think about what it looks like as it passes through your program. Like, my C code got a lot better when I learned Haskell and when I learned about Lisp, and when I started thinking about programs, when I learned more than just imperative thinking, right? Thinking about C programs functionally is really cool. Or at least drawing attention in your mind to the places where data changes, because that helps reduce a lot of bugs with like pointers and how things reference each other. If you know where things change and you try and write functions that, don't have state, or at least, kind of put all of your state into a struct that has well-defined boundaries and think really carefully about how functions change that struct, you're gonna immediately eliminate a lot of bugs. I think that's a really important thing. Draw a picture of how data flows through your program. RR Lucky, 43 viewers. It's huge. It's huge. We're popping off right now. I love it. Thanks for stopping by. I love when Quake people stop by and say hi in these streams. Cool. So look, I mean, we've got something that kind of works here. I just really want to be able to move the camera. And that is just giving me grief here. I wonder, okay, so what if rather than like rotating the camera, what if we just pretend the camera can't rotate? What if we just like move the position a bit? That would be a nice place to start. What coding languages do I know? Oh boy. So I've done most of my work in probably like Python, Java, JavaScript, C. Those are kind of like the main four that I use. I'm using Golang for my day-to-day job at the moment. Password leaked. Did I do something silly? I'm using Golang in my day-to-day job, which is fun. I'm getting a good chance to learn about that. What else have I done? I've done bits of Haskell. I don't want to oversell my Haskell ability. I think Haskell is really cool. I want to learn more about it. Dennis Maximov, thank you so much for the follow. Lisp, I think, is a really amazing language. I've actually played around with running Lisp on a PlayStation 2. There's a small interpreted scheme called Chibi Scheme. And so I actually ported that. I got it running on a PlayStation 2. I didn't get anything happening with it. But yeah, my hands are visible in the camera feed. You could use machine learning on the audio to figure out what I typed. Good luck to you if you do that. HTML, CSS, JavaScript, PHP, SQL, Python. That's a pretty good mix. You can go a long way with that. JavaScript and Python, powers the world, right? I think it's safe to say that my camera is not moving. This cube is fixed in place. It does look like the rotation might be changing slightly. Something weird's happening here. Main. Okay, so let's rotate on one axis. This is the jankiest way to test this imaginable, but let's rotate on one axis. Let's move a little bit faster. Yeah. C doesn't like that. Okay. So we're rotating on one axis here. Is the cube supposed to change size? I think it's slightly skewed in one direction. I think that's the problem here. Well, I think that's one of many problems here. Interestingly, as I believe I'm moving the camera... Oh, well, hold on, no, but our camera's looking at a fixed position. So this should be rotating around the cube. So actually, if we... I forgot I changed this. Okay, so if we go back, if we stop the cube rotating, then as we move the camera, we should see the cube rotate. And that's kind of correct, right? That kind of... Imagine not using make in Vim. It's because I'm actually because I'm running a separate program, right? I think it's easier to do outside of Vim. I think you get I don't know, the logging is kind of different, right? Fractal Mine Mike, another raid. Party of 61. Oof. Man, what's going on today? What's in the water today? I love it. Is this the time to stream? Is this when everyone's is this when the programmers come out on Twitch? Huge raid. See you using your emulator. Are you a PS2 SDK dev? Love it. Came in with a raid. Awesome. Just doing game dev. Yeah, love it, man. Haven't heard of your channel. I'll be sure to check it out. PCSX2 dev. Awesome. Also, you've got a spinny Quake logo. Are you a much of a Quaker? Because it's funny to see a Quake emote in my chat. Because my main thing before I started being a code streamer 2 or 3 weeks ago is first-person shooters and Quake. Anyone who works on PCSX2 is awesome. This is when programs aren't on Twitch. Oh, awesome. There we go. Those are some awesome emotes. I love it. But yeah, no, PCSX2 devs are incredible. They're super geniuses. I can't even imagine the work that goes into... Well, I can. I've read the code. But I can't imagine doing the work that goes into PCSX2. Retro game streamer mostly love it. Love a good bit of retro PC stuff. It's some of my favorite stuff. So, if I go into main.c, okay. As we move our camera position, let's also move our camera target. This is ambitious, okay? I want to see this cube move across my screen. Once I can move a cube across the screen, then we're getting somewhere exciting. It's not quite right. Oh dear. No matter what I do, this cube always stays in the center of the screen. And that's a problem. Australian as well. I love it, yeah. So I'm from Adelaide. So I'm from like the civilized part of Australia where we don't have accents. I made the Gmail logo, yeah. Is there a letter in there? There shouldn't be. Scared to Death, thank you so much for the follow. Sunny Veld, thank you so much for the follow. I hugely, hugely appreciate it. Now, what is actually interesting there, if we just go back, if we run our elf. So these vertices are being colored by depth, and some interesting stuff going on. Sunny Veld is also a talented dev. I love it. I would love to actually network with some devs. Thoughtless Deed, thank you so much for the follow. Hugely, hugely appreciate it, guys. Like this is incredible. This is more than I ever expected from this stream today. But yeah, no, it's been awesome. Like just having some cool devs come by and stop by in this chat and give perspectives on things. Am I trying to recreate the Gmail logo at sea? I wish. You had no idea there was a place in Australia without accents? Legitimately, okay? Like in the founding of white Australia, everyone always knows about like the convicts being sent over from England, and the convicts were sent to the East Coast. And Adelaide was not settled by convicts. It was settled by people who like chose to come over from England. So Adelaide doesn't have as much of like what we in Adelaide like to call like the bogan accent, right? There are parts in Adelaide that sound pretty freaking bogan. If you go like northern suburbs and stuff, or if you go to like Noarlunga. But yeah, no, I'm very lucky. I grew up with a very neutral accent. Oh, holy crap. So we have Thorwinius, we have Mr. Eridan, we have Standard Error DK. Thank you so much for the follows. I love it. Big D used to program QBasic in the 90s. That's huge. That's incredible. What was it like working in QBasic? Like, are you like, do you mean like in a professional capacity? Are you like building programs with it? Accent to some people. Yeah. I definitely have some accent, right? It's just a lot less. It's not your standard Australian accent. Oh man. Any 3D math wizards here? Anyone able to tell me where I'm going wrong? So I'm thinking about what this looks like, right? This is so I'm a little bit confused, okay? We need to do 3D math. We have a model space, right? We have a model. We need to put that into world space. We need to put that into our like viewport space, right? And then we need to put that into screen space. Or like I guess our camera space. Now, when I look at the functions I have to do this, we're pulling in a create view screen from PS2SDK. So this part is taken care of by the SDK. That's the wrong. We have our lookout matrix, which should be this part. And I'm using an algorithm for this, which I know works. I've done it before. And then our model to world, this is easy, right? This is just your translation, scale, rotation. And I think I'm multiplying them in the right order. That's also very important. I'm multiplying our world to view by view to screen to get world to screen matrix. And then for each mesh we're drawing, we're creating a model matrix, and then we're multiplying that by our world to screen matrix. Am I 3D? I am indeed 3D. I can confirm that I have at least 3 spatial dimensions. Okay. And for some reason, despite all of this, it's specifically our view, right? So I guess the other thing I haven't tried is changing the position of the cube. So if I can actually move the cube by changing its position rather than the camera's position. So let's pretend the camera doesn't move again. We'll get rid of this scale as well. I was growing the cube. That was like my initial test, right? Make the cube bigger. Linguistics master's degree. That sounds pretty awesome, honestly. I love a good bit of linguistics. I don't know. I like different dialects of things. The way people express themselves. It's kind of interesting stuff. I imagine it would get exhausting all the time. Inst.position.translate. What did I call this? Mesh. I've got some leaky abstractions here. We need to clean this up a bit. We're kind of mixing loading a model and moving a model and drawing a model and some hardware components in here. We're gonna as this grows segregate things a little bit more. But for now, we're just gonna live with this. I think it must be in draw.h, right? Model instance. We're calling it translate 0 So let's try and move the X coordinate as this goes. And that works. So we do actually have enough here that we could build a very simple fixed camera game, right? Mollega Linguini. What code is it generating for those translations? If it's doing the chance it's screwing up. Interesting. Okay, that's actually really interesting. So let me show you the code. It's using, I think it's using VU0 in macro mode, right? That's what these are. Yeah. I shouldn't show this on stream, but this is like the system hardware manual, right? So it goes into all the details. I was looking at this before. It talks about like the pipeline structure. It goes through all the instructions and stuff. And yeah, this is the section on how it runs in macro mode. Cop2. Okay. Oh, Cop2. Sorry, I thought you meant Cop1. Doing a lot of Cop2, div square. I don't think it's doing div and square root. I think it's just doing VM adds. Yeah, sorry, I misunderstood you there. But yeah, should I like, okay, I do actually have, that's good, cool. I do actually have a version of that. Well, so again, this is all written by people much smarter than me. This is like the standard PS2 SDK stuff. I do also have, if we just like, if we go into, where are we? I did generate my own version of this, right? Just the dumbest way possible. I wrote a Python script that manually wrote out the whole 4-dimensional matrix multiplication. But if there's a better alternative, you know, I would rather use it. Okay, so that's good. So it should, the actual multiplications seem to be running, right? And it's a good sign that we can actually move a cube across the screen like this. It's much more likely that my camera code is the problem here. Your proof of the generation, thank you. I love writing a good Python script to automate a dumb job. The other interesting thing, I guess, that is worth maybe quickly showing, if I just go workspace, PlayStation 2, I wrote a fantastic script that loads in an object file and writes it out into a format that is mostly compatible with how we want to draw stuff on the PlayStation 2. And it's literally the dumbest way of packing floating point numbers together, but it just craps it out, we load it up, we fire it in, we do transformations in place, and then send it off to the GPU. What am I doing? I'm making, eventually, hopefully, homebrew games for the PlayStation 2. Why is it you have no clue what's happening, but you still enjoy streams like this? It's exciting stuff, right? It's cool seeing this stuff come together. It really is. I love watching people work on coding projects, even if I'm not 100% over what they're doing. It's just exciting. All the code you write's dumb Python code. Oh, that is unfortunate. That's unfortunate. Sounds like a good pipeline. Thank you very much. Eventually, again, so if we look at what's happening in draw.c, we're doing this transformation in place. We're doing this transformation in place because eventually we're going to send this over to one of the vector units on the PlayStation 2. And because it has a limited memory, I think it makes the most sense, and just in general with how it's kind of set up, I think it makes the most sense to try and transform from, model space into screen space in place where possible. Otherwise, you have to keep track of two memory addresses, I guess, right? It's easy to just keep track of one. How do I validate my lookout function? I don't. I just write it and I copy something I've done before and I hope it works. So does this look right? I don't know. This is the right algorithm, I'm sure, right? It's hold on. I'm pretty sure this is the right algorithm. Let's normal. Can't help you there. 3D stuff. Yeah, that's... I'm not one to like question or change the 3D stuff too much. I just want it to work. So z-axis is normalized at minus I minus, have I done this backwards? I might have just done my subtraction backwards. That might be part of the problem. But that would just mean I face backwards, right? So that shouldn't be a huge problem. Take a read of this. Row major left hand. Okay, so there is actually like some stuff to consider here that I'm maybe not thinking about enough. Rotation. So x-axis is cross of up and z normalized, and then y is the cross of z and x, and then we have, oh, this loop is really gross. I wish I hadn't have done it like this. 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 4 times I plus 1. I wrote this loop a little while ago. I'm gonna have to think about what it actually does. But it looks good. This feels right in my soul. Matt Glad, by the way, thank you for the follow. I can't remember if I called that one out. This feels right to me. This feels right. That's how I validated it. 4, so 3. So this would be 3, and then 7, and then 11. 3, 7, 11. So 0, 1, 2, 3. No. 4 times 1. 7. 1, 2, 3, 4, 5, 6, 7. Negative 1 minus ci. Yeah, so this is the translation part of the matrix, right? So what's interesting is it looks like this guy doesn't have the translation part. But then he has this stuff along, I don't know what this is like rotation stuff, right? Is it? I think. Anyway. But this is right. This is fine. X, Y, Z. Row major versus column. Yeah. I think this is actually, you're right. You're completely right. This is sideways. So negative 1 times C and C. So do I have to normalize the dot product of try it and see if it works. That's how I validate, especially with 3D stuff, right? You just have to draw it and see. I can't do the math in my head that quickly. So they're taking the dot product, examining that and adjusting the camera position by a small amount based on projection of the new basis vectors onto the position of the eye camera. This sentence vaguely makes sense to me. I did linear algebra in first year uni maths, and that was a long time ago. It wasn't that long ago. I've just forgotten it very quickly. Expanding it to a 4 by 4 zeros, single 1 in the bottom right corner. Do I have a 1 in the bottom right corner? I start with the unit matrix. That's fine. Identity matrix, I think, is the correct term. I don't know why they've called this unit. That's kind of weird. Canadian Corndog, thank you very much for the follow. I hugely appreciate it. Seriously, this stream, I am feeling some love right now. It's incredible. It's incredible. Multiplication yields the equivalent of the dot product in the bottom row in your example. Then using the negative I point coordinates, multiply the two matrices together. Hold on. That sounds interesting. Okay, so he expands this out to a 4 by 4 matrix, builds a 4 by 4 translation matrix. So 3 by 3 rotation matrix, that's this bit, and then translation matrix, that's this bit. But this guy's saying he multiplies them together. So maybe I can just like add another bit in here. Maybe I can just like make another matrix. Let's call it T for translate. Let's say T. This is going to be like the rightmost. So it's going to be 3 equals negative 1 times CI, C naught. Then we're going to have the next row down, which is this plus 4, which is 7. We're going to have 11, and then we're going to have... Do I ignore W here? Do I put W in here? Can I printf debug? I can. I probably should, but I don't think it's going to do much to help me because it's just going to spew a bunch of if I just print out like vertex coordinates, it's going to spew a bunch of garbage out. It's not going to do loads for me. I guess maybe print out the matrix, right? Like print out the final MVP matrix and make sure that makes sense. That might be a good idea. If this doesn't work, I'll try that. 1, and then 8 my curly brace, 2, and then let's just multiply these together. So let's say matrix multiply, vector multiply, matrix multiply. Does this accept, is this going to be okay if input and output are the same? Oh, this is not obvious, is it? This is memory. I don't really actually get the this format for like inline assembly. I only know the other one. SQC. So, oops. SQC here is an instruction for sending data from the vector unit to the emotion engine, and LQC is an instruction for the opposite. It's loading into the coprocessor in this case. So it loads these things into the registers, and then it writes them back. So yeah, so input and output can be the same. In conclusion, out, T. Input. Let's see what happens. Hold on, I need to get rid of you. Let's see what happens. Something. Nothing. Okay, so we're going to come into main. We're going to stop the camera moving just for a hot minute. We're just going to try and draw the most boring thing possible. Need to initialize T. Thank you. Thank you. That's the kind of thing that I'm going to forget. Where did I... Math. Matrix. Unit T. A unit... I really am not comfortable calling this a unit matrix. Like... It feels very dirty. Okay. No. Perfect. That worked. You're a lifesaver. So let's do something. Oh, I'm so excited. I'm trying to type in capitals. Let's move the camera. R camera pos 1.0 F, I guess. Let's move slowly for now. Okay, so we've still got some problems. We've still got some spinny problems. Why doesn't he just do this with the VUs? I'm gonna get this working on the CPU first. The 3D math is gonna be the same. So the goal is, like, the only part of this that's actually gonna change when I go to the VUs is this function, right? So I'm gonna do this multiply on the vector unit, and then I'm gonna do like this. Where is it? The apply, the like multiplying a vector by a matrix, and then I'm going to do this conversion. Like, this is the only part that's actually going to happen on a vector unit. Drawing the Gmail logo on a PlayStation 2. Look, worse things have been achieved in live streams. But yeah, no. Vector unit code, absolutely going to happen. I'm gonna try and write some very optimized vector unit code. I would love to try and write a program that generates optimized vector unit code for very specific things, for like a subset of what the vector unit can do, right? Like an optimization, like you write it in Agda or something, I guess. You know, use it as a, well, but not just a compiler. It's kind of like a what's the word I'm thinking of? Like a logic solver thing. I don't know. It goes a step beyond compiler because of how the like instructions have to be lined up. Yeah, it's like a very specialized optimizer, but I think it would look more like, or you could make it look like a formal proof system. I think that's what I'm trying to say. So, okay, hold on. Let's focus up here. Okay, let's go into draw. Let's log what this matrix looks like. So, log matrix. We'll just write a function to do this real quick. Matrix M. I less than 4. J. Just gonna hard code this to 40 matrices. That's fine. So. Oh, is this gonna? Actually, no. Let's just printf one whole line at a time. So f.2. Is it 0.2f or f.2? It's 0.2f, isn't it? I don't want these to be like super long numbers. 0.2f, 0.2f. New line. And this is going to be m. I times 4 plus I times m I times 4 plus 1. Let's remember this somewhere. Base equals m I times 4. Let's actually just call it b because typing sucks. B m b plus 1 m b plus 2 and then m b plus 3. Let's see. I should probably actually mark where it starts as well. That was a bit silly of me. Okay, so printf okay, so what do we see? First off, this is a really big number. That might be too big of a number. That looks slightly suspicious. As scale, this is like rotation, this is translation related. So if we look here, as we move our camera, this number is what's changing. So if we imagine multiplying, so if we're multiplying by, so row by a column, right? So x, y, z, w, x, y, z, w, x, y, z, w, x, y, z, w. X, Y, Z. So your Z's supposed to be big. I really want, negative 20,000 Z. That's the goal. That is the goal here. No, this is not what I want to happen. And so that's probably why the colors are cycling so weirdly, right? Because we're coloring these vertices based on depth. Because that just kind of made sense when I was struggling to get depth working. Like that was a cool visualization for it. This isn't right. This is not right. C-Films, thank you so much for the follow. Arsan, I don't know if I actually called that one out as well. Thank you very much. Or Ausan. Thank you very much. Loads of awesome follows today. I really appreciate it. How do we stop our Z getting big? At least we have something we can look at now. So potentially, maybe looking at like this issue where we have mixing of like column and row matrix, column and row major matrices. Again, if we imagine what this looks like, right? So this is 0. So if we come back into our friendly drawing pad, we have this like x, x0, y0, z0, x1, y1, z1, x2, y2, z2, and then we're just filling the rest out with zeros except for this one. And then we're multiplying that by a matrix, which looks like 3, 7, 11. So it's 0, 0, 0, t, x, 0, 0, 0, t, y, 0, 0, 0, t, z, except it isn't. I'm silly here. These are ones. We're starting with a unit matrix, because otherwise this doesn't make sense. Cool, so this is a 1. Oops, it's a little bit too small. This is a 1, this is a 1, this is a 1, and then 0, 0, 0, 1. Okay, so we multiply these together, and that is going to look like row by a column, row by a column. 1, 2, 3, 4. 1, 2, 3, 4. Wait, I've got to do it plus. This is going to take forever. I don't really see how this is going to row by column, row by column, row by column, row by. Think a computer may be able to help. I don't trust it. You know, when my computer is spitting out, when my computer's spitting out this, I don't trust it. Sometimes you have to intervene and do the stuff by hand. I'm not going to multiply this matrix by hand, but in conclusion, I'm losing track of where everything is here. In conclusion, well, hold on. So the other thing here actually, math.c. So what I'm saying is, our I is moving and our C is moving. So this should stay. But, So we subtract either I from the center, I from our target, or our target from our I, right? It doesn't matter which order you do that in, it's fine. But then down here, we just do something based on the center, like the point we target the camera at. I don't know if that's... I guess that does make sense, right? Because we're kind of moving things relative to that. But are we moving things relative to that, or are we moving things relative to... No, because we're in world space. And in world space, things... are positioned, like, according to this. So there's some translation that happens here. And that gets done before this because it's on the right-hand side of the multiplication, right? When you multiply a chain of matrices together, the things at the right-hand side are applied to the vertex first. I think. That makes sense, right? Someone correct me if I'm wrong. I'm rehashing... when did I do first year... When did I do first year linear algebra? That was in 2017. I'm rehashing 4-year-old linear algebra. Duke Donuts, thank you very much. I'm losing my mind here. I need all the support I can get. Wolfram Alpha. Oof. This man has typed it out. It's the only way you can follow what's going on. Thank you so much. He's done it. He's only gone and typed it into Wolfram Alpha. What a madman. What a madman. Unfortunately, I can't bring it up on stream because I don't have chat up on this computer at the moment. I only have it on my laptop here, which isn't great. I really should do it. Wolfram Alpha doesn't understand your query. Did that get truncated? SSH into your laptop and dump its clipboard. That's the dream. So as the first component of this gets bigger, we shouldn't expect to see a Z balloon to huge. That's pretty cool, actually. It's not a bad thought. I like that a lot. On the whole, I might actually like flip my setup and program on my laptop and then stream via my PC, but like have stuff going through the laptop. Oh, yeah. It kind of freaked out here, didn't it? It didn't like the whole link. Thank you. Let's see what it says. Wolfram Alpha. Here we go. This looks pretty good. Okay, so we expect... I guess this is only part of the pit puzzle, right? Because then it gets multiplied by some other stuff. So this gets multiplied by, in draw.c. If this wasn't a PlayStation 2 project, by the way, I would just pull in GLM or the C version of the GLM library, and this would just all work out the box. Alright, so we multiply world by... Am I multiplying my matrices backwards? Could that be part of the problem here? Yep. What order... When you have a model view projection matrix, you multiply by projection first, right? Or do you not? The matrices are multiplying me backwards. I feel like I'm being multiplied backwards at the moment. Whatever that feels like. Hold on. Projection times P. Yeah, so you do it. Yeah. They're applied backwards from the order they're multiplied by. So world to view times view to screen. So this is backwards. To get world to screen, I multiply view screen by world view. Yeah? No, I'm right. No, they get applied backwards. So we go view to screen, world to view. Yeah. And then model. So yeah, no, that's right. I'm getting ahead of myself. I'm getting worked up over this. Oh, thank you to the all the people who are sticking around to watch me slog through this. This is the not fun part. And then the next stream is going to be the one where cool stuff starts to happen, hopefully. Because if this doesn't work this stream, I'm going to go off camera and I'm going to make it work, okay? Because 3D maths is just so miserable. So see, the other thing that's funny about this, in the past I've flipped Y, like in like my projection matrix or in my, in one of these other matrices, but really I can just actually flip my Y coordinate here. That's kind of unnecessary. You dodge the bullet on 3D. Oh, it is just such a hassle, and it's so hard to troubleshoot when things go wrong, right? So the other thing I guess that's worth thinking about logging, right? When we come in, maybe we need to actually log more matrices. Maybe more logging is the answer here. So let's log in order. First off, let's just log a quick line. So we'll start by logging, where is it? The world to screen. So the view projection part of our model view projection matrix. And then we're going to log, we'll log the part we know works as well. And then we'll log the result of multiplying them together. So we expect this to not balloon Z out to infinity, but not infinity, but like, 20,000, basically infinity, when you're working in a world that has, when you're expecting a number in the range of 640 by 480. Sorry, just fiddling with a few things here. So let's see what happens when we log this. I think, don't judge me for this like really janky macro work. Actually, this has been bothering me as well. Okay, that might be. Hold on, let's fix this. Oh no, let's not fix this error. Screw it, it'll be fine. Okay. Here are our matrices. So here we see the weirdly big Z, and then that gets multiplied by this. Wait, why is that? Why is our model scaled so big? Why did I do this? That might explain why the Z's so huge. We're actually drawing a really big model. Draw a sphere instead of a cube. Not a bad idea. The algorithm for like triangulating a sphere is pretty simple, right? So it's an easily solved problem. What am I doing? We're going into main, and we're going to find where we initialize our instance, because for some reason we're setting the scale. I think this was a problem. The less said about that, the better. Okay, so this is a little bit nicer. We still get a really big Z though. So what's this? Where does this come from? I mean, I guess it makes sense, right? Like we're multiplying this by 10, and so it gets 10 times as big. But where does this come from? Why is this so much bigger than everything else? So this matrix, right? It's a scale. The scaling looks fine. I don't know why this should probably be a 1, not a 0, right? Just write a ray tracer. Perfect. You can actually do ray tracing on a PlayStation 2 in some interesting ways, and one thing that would be fun to do at some point is to write a ray tracer that runs on the vector units. I've seen some people do it in the past. There's a cool video from, I I think it's a conference in like 2002 or 2003 where they demo PlayStation 2 programs just running on the vector units. Standard Error DK, thank you so much for stopping by. I will hopefully catch you later. Cool. I think this should not be 0. That gives me a bad vibe. I usually want a 1 in my W. And then what's this? What does this represent? This is part of the rotation, right? This is like Z. Is this a Z rotation? Or is this part of our X rotation? I don't know. Either way, this shouldn't be so big. I guess it's part of Z rotation, right? Because it gets it goes to the Z. Is that right? I don't know. I need some 3D wizards here. I need some 3D wizards. Okay, what if I just don't do this multiplication? What happens if I just ignore this? The X component of the Z rotation. Yeah, that's what I think. And then we're definitely initializing this to a unit. What if I just ignore this part of the matrix for now? What happens? That looks better, but nothing's moving still. It gets rid of that. So it does seem like we're doing something wrong here, right? Maybe 3, 7, and 11 aren't the right indices for this. I guess the other, because the other example had these along the bottom row, right? But I wasn't sure if that was row major versus column major. I'm just going to try it. I'm just at a point of this stream where I'm just going to try it and see what happens. So that would be 11, 12, and 13. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh no, hold on. That would be 12, 13, and 14, right? So what happens? What happens here? What happens here? That works. That was it. You can use Control-I to increment a number. Yeah, I know, but like, I always forget that one. Thank you very much. I do actually really appreciate Vim tips. I've picked up a few just while I've been streaming. I'm always trying to improve my Vim. I am always trying to improve my Vim. And that actually just worked. We are moving our camera. Confirmed camera motion. My mind is blown right now. I don't really understand what I did, but I fiddled with some numbers and then it worked. Yeah, man. Control-A. I always miss it. It was look at it all along. I was pretty confident of all the parts I was pulling in that the part I had written was going to be what was causing the issues there. I should have known. But yeah, that debug printing actually really helped. That helped me hone in on what had gone wrong. So what I want to do, I want to go into main and I want to play around with this some more. Especially I want to play around with the depth of our camera. So I think our camera is like quite a long way away at the moment, right? Our position is, 400. So what we're going to do, we're going to decrement this position and see what happens. Our camera pos 2 minus equals, let's go like 0.4 f. And we are going to hopefully zoom in on this cube. I was having problems with depth before. Printf is your religion, especially with embedded stuff, right? Like it just is such a lifesaver. So is this cube getting bigger? It's hard to tell right now. It might be getting bigger. It might not be getting bigger. These depth numbers are changing. It's really printing a lot of crap right now. I feel like I'm like horribly throttling this log. Is this getting bigger? I can't tell. I need to make it faster. I was kind of going to hopefully wait there, but I'm too impatient. I need to make it faster. I also need to remember what line number this is. Let's go 4 at a time. 10 times faster. And it really doesn't look like it's getting bigger, does it? This is not coming any closer to the camera. Is the frame limiter off? That is, it is not off. It is absolutely not off. Oh god, there goes my CPU fan. Also, Refraction PCSX2, what do you think of these EE usage numbers, right? Does this seem a little bit high for what I'm doing? Because I'm literally just transforming the vertices for one cube and drawing them. It is... could it potentially be, I guess, the way I'm waiting for VSync that could be chewing up cycles? Because this number just seems kind of ridiculous. There's no way I'm using 63% of the EE core. Might be a lot of wait loops. Yeah, that would make sense. Okay. Depth still doesn't work. X and Y works. Depth does not work. So maybe a fun thing to play with next would be to try and do controller integration, and then we could actually like get a controller, move around, and investigate this stuff like, you know, a bit more interactively, rather than having to jump out, change things, recompile. That might be good. That might be good. I guess the other thing we could try is to say inst translate to, let's move the mesh towards the camera. Let's move it quite quickly and just see what happens. Make run. Okay, so let's do that a little bit slower because that actually worked. It just isn't getting projected properly. So if we go in, let's do this like 5 times slower. Our vertices are colored by depth. So as this gets brighter and brighter, it's moving towards the camera. It's just not actually being projected properly. And then it wraps around back to 0 because we're coloring our vertices really naively, and it actually starts getting brighter again. So every loop of this is like getting closer and closer to the camera here. So these matrices at no point are actually projecting properly, right? We're transforming into screen space, but we're not projecting according to the depth of the camera. And I don't know where that's supposed to happen, right? And this is kind of what I was saying before. We've got these steps, but I feel like something is missing. And I'm not exactly sure where... Do I just need to... Am I just not dividing by W? Is that it? Is that all I'm missing here? Once I've applied, do I just like divide each of these coordinates by W? Or does that automatically... Well, that should happen here, right? I would think that happens here. Let's go to apply. Well, no, it isn't, right? It isn't deprojecting it. Of course it isn't. It's just multiplying it. So let's say V0 equals V0 divided by V3. And then... so 0, 1, G. We'll come in. I see your control A and I raise you it's find and replace. Is this it? Is this it? Oh dear. Invalid operations to binary. Hold on. That doesn't, what's V here? V is, oh, sorry, it's a pointer to a vector. Yep. Oh no, it isn't. It's a, yeah, but a vector is just... Okay, I'm going to reference this by pos instead. It should be fine. Hold on. Let's use v pos. Okay. Should be fine. We lost it. We lost it. Hold on. Let me rerun and see what happens. Okay, that was doing some depth. That was doing some freaking depth. That was moving perhaps too fast for us to truly comprehend it. Or our depth calculation is kind of dumb. One of those things. But let's see what happens when we run it. A little bit slower this time. There it goes, straight through the eye of the camera. We have depth. It just wasn't being deprojected. You multiply by the W, you divide, sorry, by the W component, or you multiply by the reciprocal of the W component. It puts you into 3D space because magic. We've got a camera. We've got a 3D camera running on a PlayStation 2. My mind is being blown more and more as the stream's going on. So, that is so cool. That is so freaking cool. I'm really excited by this right now. Let's like move our camera a little as this happens, maybe. Well, here's another thing, okay? Let's set our camera target. Camera target 0 equals inst.translate 0. So let's target our camera at our mesh instance. And then we'll like inst.translate. Well, we've got to move it first. Okay, that went, 10, a speed of 10 is a little bit too fast. We've got to slow this down a little. Let's go 0.1. Let's go like much slower. Okay, he's a long way away. Where's he going? I don't know where he's going right now. Oh, he's coming closer. Okay, he's very skinny. He's very narrow, but he's coming past. Okay. That is really cool. We've made some good progress today. I'm going to call it there. I have a lot of viewers. I would love to keep going. Unfortunately, I do have some real life commitments that I have to see to. So, I'm going to clean this up and commit this in. We have we've got a branch here for stream 2021, 15th of August. If you head over to github.com/phylum, you can follow along with the code from this series, stream by stream, first person Tron. That would be cool. But yeah, I've got my PS2 homebrew live streams repository. You can follow along. I need to set up a default branch that's a bit better than this. But if you want to see the code I wrote on the 11th of August, here it is. Thank you so much for the host. Seriously, Refraction PCSX2, amazing. Great to have you following. I would love to have you stop by whenever. Your PlayStation 2 domain knowledge would be hugely useful. Fractal Mind Mike, amazing host. I appreciate it so much. Stranger, amazing host. Seriously, it's incredible. H2 Jono, thank you so much for the follow. Hopefully I can see you guys around again. You guys are so welcome. Be sure to check it out. Also, if you want to follow my stuff, coding.tommarks.xyz. This is my website. Come and learn a bit about me, see what I'm doing. You can get all my socials and stuff. Seriously, this has been amazing. I'm feeling very loved right now. Hopefully I see some of you guys come and hang out again, and hopefully we get some more really exciting stuff happening with this PlayStation 2 now that the 3D maths is starting to take shape. It's all the exciting stuff from here. So thank you so much. I've been Tom. I'll catch you next time.